Balancing chemical equations part 1. Today we're going to learn how to balance some simpler chemical equations, synthesis, decomp, and single replacements. Those will become more important later on in the notes. But for now, for this set of notes, we're just going to learn how to do the skill of balancing chemical equations. A chemist must balance any chemical equation he or she will use in any kind of calculation, whether it be research or just get through that college chem class. So these are the suggested steps for balancing chemical equations. Again, these are suggested steps. So sometimes these steps need to be done backwards. Sometimes the whole set of steps falls apart. But generally speaking, probably about 90 to 95% of the time, if you follow these steps, you will be able to balance chemical equations much simpler. First thing you have to do is look for polyatomic ions that appear on both sides of the equation. Also consider writing water, H2O, as HOH instead of H2O. When you see it presented to you as H2O, consider writing it out as HOH, because then you will see the polyatomic hydroxide ion right there. Remember, a polyatomic is two or more atoms acting as a unit. So SO4, BRO3, NH4 in the front, those kinds of things are your polyatomic ions. So your steps are, and I would write these down somewhere on your notes, balance polyatomic ions that appear on both sides of the equation, balance all their atoms that are not part of those polyatomic ions except for hydrogen and oxygen, balance hydrogen atoms that are not part of the polyatomics, and then balance oxygens that are not part of the polyatomic. So basically, I like to say you leave hydrogen second to last and oxygen dead last. Please pause this video and jot down these steps. Welcome back. So here's our first chemical equation. First thing I'm going to do is just teach you a simple method, and you may want to Google other videos that might give you some other methods. I really don't care what method you use as long as you can successfully balance. This is just my method that I have found the most success with over the years of teaching. So the first thing you want to do is look for polyatomic ions. That's the very first step. You will notice throughout this whole set of notes that there are no polyatomic in any of my examples. That will be part 2. But for part 1, you're looking for any polyatomic ions. I do not see any polyatomic ions, so I can start then with other atoms except for hydrogen and oxygen. So we will first we will split the equation between the reactants and the products. Remember, the reactants are first, the products are second. So we're going to split the equation. I've color-coded it just so you can quickly see the element groups. So aluminum and sulfur are present. So first I'm going to put a divider, I like to say, at the arrow. I'm going to list my atoms underneath that arrow, and then I'm going to count, like we worked on yesterday, how many atoms there are for each element. I'm going to put a number on the left side of the symbol and a number on the right side of the symbol. I'll be counting the numbers. So this aluminum, there's no number with it, so it has 1. This sulfur, there's no number with it, so there's 1. This aluminum ever has this 2, because this means there's 2 aluminums. There's 2 aluminums and 3 sulfurs. So there's 2 aluminums from that and 3 from that. So now we have a 1, 2, 1, 3. So balancing equations simply means you have to have the same number of atoms on each side of the equation. So we can put numbers only in front. So I've left you lines here to know where to put numbers. I can't squeeze a number in here. I can only put numbers in front of elements or compounds. So I can put a number in this front of aluminum, in front of the sulfur, in front of here. Okay? So I need to get 2 aluminums on both sides. So what would I do to get 2 aluminums? I'd put a 2 up here. When I put this 2, I'm going to reevaluate what this aluminum changes to. So 2 times 1, this now changes to a 2. So now we have 2 aluminums and 2 aluminums. So those are balanced. Now I'll go down my list and I'll look at sulfur next. I have 1 and 3. So what numbers would I multiply by to get them both to the higher number, the 3? Okay, so what you're thinking about is what is the smallest number these 2 numbers have in common. I can get them both to a 3 by multiplying. We're always multiplying. So I'm going to put a 3 in front of the sulfur. When I put a number here, remember what that does? It tells us that we're going to multiply through. I'm just going to move this over a little bit. So 3 times this 1, then this down here will change to a 1. I like to call this my thinking or working area. Okay, eventually some of you will get rid of all this and you'll just go back and forth visually and do this. But once I put that 3 here, that changed what was 1 there to a 3. Because I'm multiplying again, remultiplying. So now I have 2, 2, 3, 3, and this one is balanced. Okay, another example. So again, we're going to isolate and identify the elements, no polyatomics, but if there was, we'd treat that first. But since there are no polyatomics, we will skip that step and then list every element except for hydrogen and oxygen. If hydrogen and oxygen are present, then they'll be second to last and dead last. So that's why I'm listing it as zinc and oxygen. Putting oxygen last because it's almost always helpful if oxygen is the very last thing you balance. So I have zincs on both sides, I have oxygens on both sides, and I'm going to look and count how many I have. So I have 1 zinc, I have 2 oxygens on the left, on the right I have 1 zinc and 1 oxygen. So let's look at that. Nothing after here, so a 1. There's a 2 after this. There's a 1 here and a 1 there. No numbers after this, so each have 1. Now, those zincs look great, but my oxygens are not, so I got to fix them. The only thing I could do is put a number where the oxygen is present. So the only thing I could do is put a number here. I can't squeeze a number in between, so I need to put something out front of that Z and O. So once I put a 2 there, that's going to go through everything, though. So any number in front goes through everything immediately after it. So I multiply through. So there's 2. Remember, there's 1 of these and 1 of these. So 2 times 1 makes that oxygen go to 2, and 2 times 1 zinc makes zinc go to 2. You can do it in any order. It doesn't matter. So I multiply through and I get a 2. 2 times what was here. Now this changes to a 2. Remember, this is my working area. I'm changing up here and then adjusting what it does down here. So now I have 2 and 2 oxygens, but now my zincs are unbalanced. So now I have to go back to the side, hence balancing, kind of teeter-totter, seesaw back and forth. And I got to put a 2 out in front of here because I have to get both my zincs to 2. So I put a 2 out in front of there, and then I think about how does that affect down here in my working area. The 2 times the 1, so now I have 2, 2, 2, 2, and it's balanced. Okay, with this example, we're going to split our chemical equation at the arrow. We're going to list our atoms, magnesium and chlorine. We're going to count how many each we have on the left and the right of the symbol for how many of each we have on the left and the right side of the equation. I have 1 magnesium and 2 chlorine, 1 magnesium and 2 chlorine, and this is balanced. You do need to tell me that you've balanced it. So if you come across one that's already balanced, you need to indicate that it's balanced. That will tell me you've looked at it and you know it's balanced, not that you skipped it because you were confused or just didn't have time. So always be sure to tell me if it's balanced. All right, next example, we're going to split the I keep saying element, I apologize. We're going to split the reaction at the arrow. We're going to list our atoms, aluminum and oxygen. We're going to count 1 aluminum, 2 oxygens on the left, 2 aluminums, 3 oxygens on the right. So now we're going to get the aluminums both to 2. Remember, oxygen's going to be treated dead last almost always. This is one of those cases where we could have done oxygen first, but you'll never know that. And most of the time doing oxygen dead last is helpful. So let me explain. So we need to get our aluminums balanced. So we put a 2 here because I need to get 2 on both sides. I put a 2 there. How does that affect down here? 2 times 1 because there was 1 before I put the 2 makes this go to 2. Now my aluminums look good, but my oxygens are off, 2 and 3. So this will happen quite often. 2 and 3 are going to come up pretty frequently when you balance equations. We need to get them both to a 6. Think about it this way. We've been doing this and I haven't emphasized it a lot, but what do I need? What's the smallest number both have in common? The smallest number these two had in common was 2. The smallest 2 and 3 have in common is 6. So I got to get both sides to a 6. So what am I going to put over here in front of oxygen to get it to a 6? I'm going to put a 3 there. So 3 times 2, and how does that affect that? It makes this 2. 3 times 2, this 2 was a 2, and when I multiply my reval, or my re-math piece says 3 times 2 is 6. Now I have to get 6 on the other side. So I got to think about what times 3. So I can put a number here. I can't put anything in between. What do I multiply 3 by on this side to get oxygen to 6? I'm going to put a 2 in front, and it makes that go to a 6. So 2 times 3, 2 times 3, I'm looking at oxygen only right now, goes to a 6. So now oxygens are balanced, but this 2 also affects this aluminum. So the 2 times the 4 is going to get my aluminums to go to 4. So there they go. Now I have a problem though, because great, now my oxygens look good. Remember, it's balancing for a reason, but now my aluminums are off balance, so I got to fix that. So I can always change any number I put out in front. The 2 is not here, does not have to stay. So I'm going to, instead of making that a 2, because I got to think about, there's only 1 here, so what would I put in front to get this to be a 4 total by multiplying? I would put a 4 there. So I put a 4 there instead of 2, and then this will become a 4 down here. So once I put the 4 in here, it's no longer 2 of these. Remember, this part down here is what we're always doing to fix whatever we do up here. So we do it up here first and then adjust down here. This is just sort of our working area, our platform to see that things balance. So I would read this as a 4, 3, 2 if I was reading you how this was balanced. Okay, next example. Again, we're going to split at the arrow. So we're splitting the reactants from the products. We're going to list the atoms. We're going to count how many we have. 1 phosphorus, nothing after it. 2 oxygens, 2 after it. 4 phosphorus and 10 oxygens on the right. And so phosphorus need to be fixed. So we're putting a 4 in front. When we put that 4 in front, we think about how does that change it down here, because I multiply it, becomes a 4. Let me go back just a second. To get these two the same, the smallest number these two have in common is 10. So meaning I can get them both to a 10. I can't get 2 to anything. I can't get 10 anything near a 2, but I can get 2 up to a 10. So we're always thinking about what do I multiply to get them both to the same. Smallest thing that they both go, I can get them to. So I'm going to put a 5 in front. Remember, I can only put numbers in front. 5 times 2 makes this go from a 2, because I'm reevaluating. When I put a number in front, I reevaluate, makes this go to 10, and now this one's balanced. Example 6, this is the final example before I send you on your way to do your own work. We're going to split the reaction, list our elements. Again, all of these problems, I haven't been saying it for every example, but you should be looking for polyatomics. None of these have had polyatomics. We will work on that at part 2 of notes. 1 Bi, 2 Cls on the left, 1 Bi, 3 Cls on the right. So I'm going to put a 3, oops, let me go back to explain that a little bit better. So I see Bi and Bi are 1 to 1, and we have 2 and 3 chlorines. So the smallest number, remember 2 and 3 are common, I get them both to a 6. So what do I multiply by on this side to get it to 6? A 3. And when I do that, it becomes a 6. And then, so now I have 6 and 3, so what do I got to put in front of where chlorine is on this side? I got to put a 2 in front to get it to 6. So I put a 2 there in front, and this becomes 6, and now we have 6 and 6 for chlorine. But don't forget that 2 in front affects everything immediately after it. So not only did that 2 make the chlorine go to 6, the 2 also made the bismuth go to 2. So now my bismuth become unbalanced, so I have to fix the other side. So I got to think about what do I put in front here to get a 2? I'll put a 2. And when I put that, this goes. Now we're balanced 2, 2, 6, 6. That concludes my examples. Take as many times as you need to go through this. You will be practicing some of these on your own. Remember, you can only put numbers in front, and they can only be whole numbers. Have a fantastic day.